9, we're going to be studying static and kinetic friction. And to do that, we're going to be using a cart and some blocks. So we're going to be using the cart in order to push the blocks. And we're going to be able to test the friction by testing the different inclines that it's at.
We're going to use the next ones. We're going to use a card that's going to be the one that we're going to be pushing in order to calculate the data of our experiment. We're going to use a block that's going to cause friction for the card in order to calculate the coefficient of static and kinetic friction. We're going to use a track, which is going to be the one that we're going to use in order to measure the motion of the cart. And lastly, we're going to use a ruler that is going to help us to measure the height of the inclined plane in order to calculate the angle.
The experiment, it has to be on the flat surface, so we're going to be doing it just on no incline, and we're going to be using the cart to push the block. For it to be static, it does not need to move, so we're going to apply very little force of it. And then for the second part, we need to apply more force in order for the block to move. Yeah.
Second part of our experiment, we're going to be doing an incline plane. So to do that, we added this little gel box and we measured the distance from here to here, and it turned out to be 14 centimeters, and the hypotenuse turned out to be 120. So to calculate the angle, what we're going to do is use the inverse of sine, and we're going to be doing the opposite over the hypotenuse, opposite being 14 centimeters and the hypotenuse being 120 centimeters. So for the angle, we got 6.7 for the angle, and we're going to be doing the static, which is not moving, and the kinetic, which is moving.
Part of the experiment, we're going to do the same as in the first part, but now we're going to be pushing the cart with a force. We're going to be applying a force much greater than the last time in order to get an acceleration.
For the fourth part of our experiment, what we're going to do is do kinetic friction. So we changed the angle, and now instead of being 14 centimeters, it is going to be 32.5 centimeters. So then to calculate the angle, we use the opposite over the hypotenuse, which is 32.5 over 120, which is the up sign, negative sign, and we got 15.7, and we're going to be testing it.
Going to be explaining our data analysis that we got from lab number 9. So first what we did was with our first equation, which was the coefficient of friction equals the force of P divided by mass times gravity. That was our first coefficient of friction equation. So what we did was calculate the force with our graphs using the system, and for static friction we only moved it very, very slightly, and for trial 1, after calculating it using the force we got 0.12, for our second trial 0.15, trial 3, and 0.11, giving us the average of 0.13. And then for our kinetic friction, what we did was we pushed the little car a little more constantly so we can get somewhat of an equal force. So our first trial we got 0.12, our second trial was 0.15, third trial 0.13, and for our average we got 0.13. And then for our second equation, which was coefficient of friction equals tangent times theta, so we added some height to one of the inclines to make an incline plane, and using sine we got tangent of 6.7. So 6.7 was our angle with the incline plane. So since the coefficient of friction just depended on the theta, for all of our static and kinetic friction answers for all three trials and average we got 0.44. And then for our third equation, we got, this one uses coefficient of friction equals force minus mass times gravity, all divided by mass times gravity. So for our static friction, so here for this one, what we did was calculate the force and the acceleration, and our mass was 0.2 and gravity obviously negative 9.8. So first our static friction, again pushing it slightly, was 0.12 for trial 1, 0.06 for trial 2, and 0.12 for trial 3. And then our average for that was 0.1. And then for our kinetic friction, again moving it a little more constant, for trial 1 was 0.19, and then trial 2 was 0.15, and trial 3 was 0.14, giving us an average of 0.16. And then for our last equation, this one was a little more complex, but to get the coefficient of friction for that, we needed to equal the numerator of negative acceleration plus gravity times sine theta, and divided by gravity cosine theta. So for our thetas, that did change a little because we needed to make sure that our acceleration for the kinetic was moving and sliding down. So for the static friction, we used the one that we used previously in the second equation, which was 6.7, using the same height. So for that, our static was 0.44 in all of trials and in all averages. And then for our kinetic, we did increase the height of it to be able to get a sliding down number. So for that, we got a 15.71 as the theta, and our kinetic, all of the trials and averages gave us 0.16 since it was at the same height, so we can conclude that it did go constant acceleration. And all of that we plugged into the formula.
Good morning. As part of the conclusion for our lab, we'll be interviewing our scientist Gabriela Ruiz, and she'll be answering some questions regarding the experiment. So my first question is, what is the importance of repeating more than once your experiment?
To be able to see if we get constant results or if there are other factors playing in that could mess up one of our results.
My second question is, what is the learning you take from today's experiment?
That we're able to calculate the coefficient of friction using different formulas and different methods and different systems.
And my last question is, how did you share your ideas to contribute to the design of the experiment?
For the fourth equation, we needed the card to be sliding down so the coefficient of friction could have constant acceleration or different accelerations and sliding down on its own, and we added more height to it so it could slide down on its own rather than stay at the very top.
Thank you.
The procedure and setup of the experiment.
Setting up the experiment, especially when it comes to the incline plane, finding an object that can create an angle and then calculated the angle that we needed to use. I also played the journalist for the conclusion part, and I also recorded this video and then I'll edit it later.
All of the data analysis, and I was the scientist answering the questions.
Sensors did the graphs and helped with the procedures.